Hello everyone, I'm Rong. I'm honored to show my pair here. The topic is color imaging, faster encryption algorithms based on JPEG encoding. Image encryption algorithms is an important research issue in the field of digital processing, image processing, computer vision, and reliable video transmission. With the increasing demand for image processing in the context of the Internet, image encryption algorithms have been widely used in key areas such as politics, economy, military, and medical care. Most mainstream image encryption algorithms are to hide data in a frequency domain and a spectral domain. So, the mainstream image encryption can be divided into categories. One is to select the log pattern of the information in the image for the encryption algorithms, so as to reduce the amount of encrypted data. The other one is to use the encryption algorithms throughout the entire image conversion encoding process to reduce the generation of compared data redundancy. This pair analyzes the characters of two mainstream encryption algorithms systematically and optimizes the whole image encryption process by the combination of image conversion process encryption and selective encryption. First, it programs squaring and equating and the original image, and then encrypts DCT sufficiency and layer-rich symbols during JPEG encoding. To realize hiding the image DCT sufficiency, simultaneously it chooses a map with better targeted efficiency as a pseudo-random number generator to generate a targeted sequence. For the encrypting algorithms, encrypting the edge imitation image blockers with richer texture by the approach of edge declaration, and then converts encrypted relevant information into the DCT sufficiency. The final theoretical analysis and experimental results show that, compared with the traditional encryption algorithms, the algorithms described in this pair is more advantageous, stable, and robust. In terms of tirelessly security, encryption covariance and This pair analyzes the characters of two mainstream encryption algorithms systematically and optimizes the whole image encryption process by the combination of image compression process encryption and selective encryption. The final theoretical analysis and the experimental results show that, compared with the traditional encryption algorithms, the algorithm described in this pair is more advantageous, stable, and robust in terms of tirelessly security, encryption, granularity, act. Encryption algorithms of JPEG color image in this pair uses indent dictation strategies to select regions with rich textures for image encryption and adopts targeted encoding strategy to realize spatial screening encryption of image. It completes the encryption operation in the frequency domain. When the image data undergoes DCT transformation, and at the same time it enters the selected encrypts information into the image data. This pair focuses on selective encryption for errors with richer image information. First, the encrypted image is divided into 8x8L. Then it selects the counting operator to detect the edge of the encrypted image, choosing a reasonable threshold T based on the moment of information at the edge of each block to complete the screening of error. There are key encrypted blocks in each block. When the digital image is JPEG encoded, it is usually necessary to encrypt the image in the airspace first, and squaring images is one of the commonly used airspaces encryption methods. The parameters used in the squaring process are inherently bounded, and the sequence generated by the described target mapping system can be used as an image squaring process. The image squaring method based on target mapping can be summarized as follows. First, using a non-targeted mapping to generate a targeted sequence HR. Second, squaring the lines of the image block mapper. Finally, multiply runs of block row and clone cyclic shift operations can achieve encryption effects. After the image is transferred by DCT, the DC sufficient holds most of the information of the image, while the AC sufficient holds relatively little information. Therefore, the substrate is adopted to realize the selective encryption of DC sufficiency using the P-injective sequence generated by PWMOCM mapping as the key string of the sequence JPEG to encrypt each coefficient. The process is shown in the following formula. The encryption of AC coefficients depends on the marking of image blockers. Using JPEG method to select the first 16 AC sufficiency from all marked blockers to encrypt. The calculation method is as follows. In algorithms for encrypting DCT sufficiency, encrypting the absolute values of the DCT sufficiency to be encrypted with serial symbols. Then it takes out the symbols of this sufficiency to formula a symbol bit sequence and encrypts them to achieve the efficient of hiding the DCT sufficient information completely. The experimental selects for representative color images in the USC SIPI image library and verifies and compares the classic AES encryption algorithms with the encryption algorithms described in this article. The experimental results show that the algorithms in this pair has better results in both the encryption effect and the encryption efficiency comparing with the AES encryption algorithms. At the same time, it is verified that the algorithm described in this article is more superior, stable, and robust in terms of time-necessary security, encryption, calculability, etc. The algorithm's encryption result elevation table is as follows. This pair mainly studies image encryption technology and designs in encryption algorithms fully according to the characters of the image data structure. Therefore, using color image comparison encoding encryption and selective encryption. This pair provides an encryption algorithm based on JPEG image composition encoding. A certain amount of experimental results verify that the algorithm in this pair is more superior, stable, and robust than traditional encryption algorithms in terms of density, security, encryption, capability, etc. Thanks.